Hello everyone, C495. Okay, today's Saturday. Uh, Today I'm just continue to create something using the Rhino and Grasshopper and transfer all the geometry data to SAP2000. So today, hopefully you can uh, now start enjoying playing with the Rhino and Grasshopper for your future project and study. All right. So this is Rhino 7. As you know, this is just the first the view when you open the Rhino 7. You see that here is one icon, launch Grasshopper. I'm gonna open the Grasshopper, but you want to make sure when you open it, I think it's automatically it may choose the one unit, but if you want to change and open the new file, right, new, and you could pick up the unit you want to start with. So I'm going to choose fit. All right, so for the window views, but I open the Rhino here, right? No, Grasshopper. Okay, so here I already pre-installed a couple of plugins, but if you are totally new, obviously you probably don't have those plugins. All these plugins you can download it mostly free from the Rhino for the Food for Rhino, some the website. So I will show you later. But anyway, so let's get started. So what I'm gonna do today, maybe I'm gonna create a dome structure. Dome structure. So there are many ways to do this, but I'm just testing how to use some the components. So here I'm gonna use at this time I'm gonna use front view is the fit. So I'm gonna, let's say, draw the one. I'm gonna use curve command and draw some sort of reference line, right? If I click it, this is the nerve curve. So any geometry later on, I can move around. So this is some just initial reference curve. I'm gonna use it. So on the, I'm click the grasshopper. I'm gonna click find out curve. So I'm gonna assign this curve I drew it, assign to this curve component. So when you click it, yeah, you see that this curve is shown in green color, which means this curve I just draw as is assigned to this component. All right, so what I'm gonna do, I'm gonna rotate polar using polar array and copy it. So polar array here, right? I'm gonna put it as 3D. All right, this is one. The curve I just draw and assign to the curve component. I'm gonna bring this one, plug it. All right, so this is polar copy, right? So polar array is upon 0, 0, the default is a 10 counts, right? Basically, you can put the 2 to maybe 10. And if you using number slider and plug in, it's gonna, you see the base upon number of count, it copy automatically around the 360 degrees. Okay, this is cool, right? So based upon do this, using this reference, I'm gonna use loft. Oh, I keep commands so that I can create some surface, right? I think it's somehow default. It doesn't default has open surface loft. So in order to close this the surface, you need to click right click and loft option, and here close loft, so you can close this. All right, so this is just one beginning setting, very simple component basically. And what I'm gonna do, I'm gonna maybe I'll just a little bit. So I'm gonna play around overall geometry a little bit. Maybe Oh, not putting it up. Maybe make an opening a little bit. So on here, click. I'm gonna click the point here. Maybe move this one a little bit, and also select this node and maybe bring up a little bit, or down. Okay. All right. Assume this is okay. So, okay, 3D. It looks like this. Maybe I need to make it a little better. Okay. All right. So we have surface, one surface ready. So now what I'm gonna do, I'm gonna use some Lunchbox, the tool in the Lunchbox tool, and I'm gonna use squad panel. So what this does do, this entire loop, they just subdivide it based upon number of x and y, right? U and U, they use U and V. Default has number 10, 10. So I'm gonna make number slider, maybe 10 to 40 in both in U and V directions. So I think so vertically, I think 10 might be enough, but X direction, yeah, I'm gonna make maybe 30 or 40. Okay, maybe, okay. So this already subdivide this one big mesh, which, right, you could click it, you see this, all the green color. So what I'm gonna do, two things from here, I need to collect I need a two component, line component and surface component, so that those two, line and surface, I can export it and import it all to the SAP2000. So in order to do that, I'm gonna first of all decompose, okay, all this, so that I divide to, first of all, curve. So edge is curve. So see that this is all curve. It's all segmented. It's straight line, right? And then surface over there. So those are two ready. So SAP, in order to make all geometry in the SAP 2000, all the line surface should be straight line, and also should be straight, the plane surface. So let's try out. So this one curve I'm gonna bake to layer 1. Okay, and the surface I'm gonna bake into layer 2. All right. Okay, I'm testing whether everything is baked properly. So this is line. If you click it, yes, you see the curve, right? If you look at it, this is, oh, this is second one is surface. All right, so now I'm gonna export this one, select it, and export to, today is number 5. This is DOM to SAP, right? So this one, DOM to SAP, and make this. I'm gonna choose IGS form. IGS. Okay, here. So IGS form, I save it and create the file. Its initial unit is fit. All right, I create it, and I'm gonna open the SAP2000. Okay. Okay, so I just opened the SAP, and I'm gonna bring, I think our unit is fit. So I'm gonna import IGS file that I just created. Click the browser. Okay, this is the one. The DOM to SAP. Okay, DOM to SAP2000. So you see the two identity. One is line, one is shell, right? To click it. Say okay. Okay, let's see. So I want to make sure this is the right dimension. Unit. The initial. Okay. The 3 feet, okay. So this is seems right. And I'm gonna turn on turn up the line. Okay, shell structure, shell element is right there too, right? So we do have both line and shell together. Because the color is a little deceiving, I'm gonna turn on the fill object shell, so it will show both, right? So this is how we can create the geometry. Rhino grasshopper sometimes is the most powerful. You probably can easily handle. There is something. Oh, the one thing I forgot actually, I can also export this initial my reference line. I'm gonna delete it. Oh, there's something hidden lines. Okay, delete it. Right. So I want you to make sure that all the line in SAP, the structural model, you need to use a straight line. There is no such a curved line. The SAP cannot recognize it. So this is all somehow you need to subdivide, make it segmented, and all the line should be segmented, but it should be straight line. Curve is the same thing. There is no such a curve element. This should be also one plane element, right? So for simple exercise, so from now on is all engineering. Before is pre kind of engineering concept. Oh, there is something left over. I'm gonna delete this, right? So typically, yes, let's assign joint, pin, boundary conditions, and default member here section. Yeah, always they have default 18 by 35, but I'm gonna use maybe pipe. So I'm gonna choose one, maybe P6, P4, P6 pipe. I didn't have a material, I'll just keep it, right? Or you could bring the material, new material. That's a pipe 835 grade B, and then you're gonna choose the material, yes, for the pipe. So I'm gonna assign this to pipe, right? Instead of W18 default member. So now when you look at it, unfortunately this doesn't click. All right, so I think what we can do, we can run, okay, here is default dead load, sulfate is counted, and the material shell a cell, I may have to change the property as well. It's a 1 fit, so it's a lot, maybe 0.1, right? Concrete, assume concrete, and I'm gonna run the model as it is. So basically we create the geometry, assign them section properties for okay, where it is, where I'm gonna save it. Grasshopper. Okay. Okay, I'm gonna save Storm to SAP example. And so the model is running. Okay, ran. The first after run, I'm gonna just check the deformation and shape due to the gravity load. Because this is shell, maybe I have to turn up the shell, or using contour so that visually vertical deflection. Cubic and draw show contour diagram. Okay, that's the okay. Maybe I prepare to turn off the shell and show the line only. Okay, this may be better for graphically. Okay, so this is alpha deflection. I'm gonna create the 3000. Wow, 5000. Okay, animate it. Okay, so you can see this. I think this is a geometry, has a vertically very steep, but when the vertical width is reaching into horizontally, obviously those areas more like the cantilever. So that I think top peak here is deflect. You can see there's some more deflection. So this is one of the examples, just kind of sequence I try to show you. But obviously, structural engineering analysis and design is next step. You need to understand all geometry and what is right and efficient structural form. So you need to understand the fundamental of the geometry there, kind of the what is that strengths and their benefit. So we need to understand the shell geometry structure, right? And the others all following is similar to the other structural analysis procedures. So, all right, I think this model is kind of done. What something that I didn't turn up is the shell element, right? Also has a stiffness, so it show relatively very stiff. I'll turn up the stiffness of the area elements and show you another model. Okay. Okay, here I just reduce the shell, which means every element stiffness almost 90%. So you could see the more deflection and amplification is increased. But you could see the overall the formation shape of the cell frame. It's more visually recognizable. Alright, I think this is kind of cool. The exercise, I want you to find something, the reason and interest and why the structural form finding is part of structural design procedure. It's not just calculations. I think we are learning, the human beings been learn a lot from nature, all the form, the pattern, right? From the nature, we implemented those understanding into our structural design and design procedures. All right. I hope you can enjoy and practice Rhino and Grasshopper a little bit. It's very simple, right? So we'll see you next.